Okay. Abhishek. Yeah. Can somebody tell me like what is the use of IPv6? Yes, Jeet. What is the use of the IP version 6? We have IPv4, right? Then why we are going for IP version 6?
IPv4 there are some terms that will be not there for connecting or giving the IP. That will be in the IPv6 more. We provide the more language and
Okay. Then bandwidth. Bandwidth. Okay. Okay. Let's say something.
Unique identities for a system. IPv4 is limited 4 digits or something. So we shift to IPv6 is 340 undecimal.
So according to you, 4.3 is a small number.
Yes,
Billion, 4.3 billion.
That's why you shift IPv6.
Is it?
Limited number.
IPv6.
I think IPv6 is more secure for IPv4.
It's secure. How come?
We don't require a subnet mask in IPv6. And these are more vulnerable to system.
Then Abhishek, any idea?
Unique IP addresses for public.
Yeah, IP addresses are unique only. After that, Pratik, what is the size ahead of this IPv6? 128 bits or bytes? Bytes. Good. Bits or bytes? Bytes. Great. Bharti? What's the size of the IPv6? 132. Is it a new one? 128 what? Kilometer? kg? Liter? Then bits. Risha. Risha. Just stop. Bharti. Please don't be quiet. Even if it is a wrong answer, please give it to me. Okay. But start talking. That's sort of what I want. Okay. What's the size of this IPv6 header? You think? Okay. 128 bits. Size is also 128. Header size is also 128 bits. I don't know.
40 bits, I think.
2 bits.
No, bytes. So
Bytes. Yes, sir.
32.
32 bits. What? Header. 32 bits. Just. Don't you think like it's very small? And let me tell you, the header size always will be in the bytes, not in the bits. Whatever the header size will be there, always it will be in the bytes. Okay. Yeah, great. IP version 6. IP version 6 means what? Internet Protocol version 6. Okay, which is the next what version of the IP version 4. Okay, yeah, we had IP version 5 also, but that was not that effective and it was not practically good. So that is why they didn't use this one. Okay, and the IP version 6 is really effective than the IP version 4. Okay, why? We'll see now. So before that, let us see like what are the number system we have, because what number system we use in IP version 4? Decimal, dotted decimal system or method we use to write this what you call IP version 4 addresses. What about this IP version 6? We use the hexadecimal numbers. Okay. Yeah, you can see here binary which is having a base 2 and the prefix value will be used as a 0b. Whenever you are seeing any kind of a binary number, if you see this one, okay, if you see this like this, so what is this? It's a binary number. So it shows that what? It's a binary. And decimal means what? It will be like 0d. Okay, something like it will be like that. Understood? And next is hexadecimal number. So which is a base of what? 16 and which may be written as what? 0xx. Okay, whatever the 0x will be there, that is called as what? Hexadecimal number. Okay, now we'll see why we exactly need IP version 6. As you already know that in IP version 4, how many addresses we have? Approximately 4.3 billion IP addresses. 4.3 billion IP addresses. Yeah, at that time it was really a big number. Okay, but nowadays it is totally a small number. Why? Because how many devices you have with you? Your mobile, your tablet, your laptop, a PC. Yes, everyone, I mean, every device they need what? Just to talk with the internet. Yes, if they want to talk with the internet, they need IP address. Then which currently which version we are using? IP version 4 still, not totally into version 6. Okay, so a single person is having, you can take average 2 to 3 devices, average 2 to 3 devices. Every device they need to talk with the internet. In that case, what will happen? This 4.3 billion number will become very smaller. Okay, can see here, though we have approximately 4.3 billion, that is nothing but the 2 raised to 32 IP version 4 addresses, they are insufficient for today's IP addressing. Why? Because it needs, due to the rapid growth of the internet connected devices, as a result, the available IP version 4 addresses are being exhausted. What's happening? Even though we are having 4.3 billion IP addresses in version 4, nowadays you can see that how the electronics market is going. Okay, so that's what I said. Everybody, they need what? They need the internet. Okay, they need what? Internet. They want to talk with the internet. They want to talk with the different devices. So in that case, they need the IP address. So that's the reason this IP version 4 is totally getting exhausted now. Okay, so initially when the designers created the IP version 4 over 30 years ago, they believed that 4.3 billion is a it's really sufficient number. Okay, but for the needs of that time. Okay, not now. But however, you can see the rapid evolution and growth of the internet have consumed all the available IPv4 addresses, leading their exhaustion. Okay, so this is a major reason behind exhaustion of the IPv4. Because of what? The rapid evolution and growth of the internet and internet connecting devices. Okay. So to conserve, it is not like we didn't try to conserve this IPv4. Yes, we tried by using what? By using private IP addresses, public IP addresses, FLSM, VLSM, NATing. So these all are what? These are the short-term methods just to reserve this IPv4. But that is still not effective. So that is the reason we have to go forward IPv6. You can see to conserve the usage of this IPv4 address space, short-term solutions such as VLSM, like variable and subnet mask, we already know that one, and private IP addresses and NAT. Still, we are not covered this one. NAT means what? Network address translation. Why we use this one? To map private to public, to map private IP addresses to the public IP addresses. Okay. So were implemented. However, the long-term solution is what? Adopting IPv6. Okay. So this is what the reason behind using what? IPv6 or adopting IPv6 addresses. And this IP addresses will be given by one registry called RIR. Okay, what is that? Regional Internet Registries. They will give the IPv4 pools to some regions, just like what? Asian region, American region, so North America, South America. So these kind of regions will be there, are there. Okay, and some of the regions they already declared officially that whatever the pool you are given to me, it is totally exhausted, and we are going for what? We're going for the IPv6. Okay. And some information about what? IPv6. You already know that. What is the size of the IPv6? It is 128 bits. Okay. So it is 4 times of IPv4. Okay. So what is the size of the IPv4? 32. If you multiply it with 4, you will get it as 128. So it is 4 times of the IPv4. Okay. So the total number of IPv4 are 2 raised to 128. Okay, if you have time, you can read this one. I'll read this one. What is this? 340 undecillion, 282 decillion, 366 nonillion, 920 octillion, 938 septillion, 463 sextillion, and 463 quintillion, 374 quadrillion, 607 trillions, 431 billion, 768 million to 11,456. It is totally unlimited. Okay. So that is why everybody are going after the IPv6, and even they don't need water. Subnet mask. Do they need? Even if you give one IP address to every devices, okay, it is totally sufficient. Yes, understood. This is not a smaller number. 340 is not a smaller number. Okay. So, for example, you can check this one. This is one of the IP address of a version 6. Okay. So 2001 colon. So how it is being represented? It is represented in hexadecimal number and separated by colon. Okay. So 85A3 0 0 0 0 0 0 0 0 8A2E 0370 7334. Okay, this is one IPv6. Is it really easy to remember? Yes, for you guys it is right. No? Okay. So IP version 6 has how many segments here? It has total 8 segments. Segments means what? 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 segments what we have in the IP version 6. And each segment have 4 hexadecimal characters. You can see in each and every segment we have 4 hexadecimal character. So what is the size of each character here? What is the size of each character? Each character in a single segment. How we write the IP version 4 address, sorry, 6 addresses. Okay, do you remember 8421 rule? You do? What is the maximum number? Maximum number with that 15. Okay. So do you think it uses the same? I think I said something about the nibble, right? Nibble? Yes. So what is nibble? What's nibble? 3 bits.
4 bits.
What's the 4 bits? Okay. So here each and every character size is what? 4 bits. A nibble you can say. Okay. If we take this 2000, 2001. So what is, I mean, how you write this in a binary? How you write in a binary? So 0, 0, 1, 0, and this one 0, 0, 0, 0, and third one 0, 0, 0, 0, and last one 0, 0, 0, 1. In a single segment, how many bits are there? Single segment, how many bits are there? 16 bits. Okay. So 16, how many segments we have? 128 bits is the size. Am I clear? Is it? So in a single, I mean the size of the single segment in hexas, sorry, IP version 6 is what? 16 bits. So like that, how many segments we have? 8 segments we have. So total it will make it at the size of IP version 6 as 128 bits. Am I clear? Okay. Yeah, that is the 16-bit binary numbers are separated by a colon. So it makes the total size of the IP version 6 is what? 128 bits. Okay. And can you see this slash 64? What is slash value in the IP version 4? Yeah, CIDR or a slash value, what it is called? Subnet mask? What it represents? It's the number of network bits. So here also we have the same slash value. Okay. And this time it is called as what? A prefix value. But it will also do the same thing. What it will do? It will also give you the number of network bits in the IP version 6 address. Clear? So slash 64 is a prefix value of a given IP which indicates that the first 64 bits of the address are used for what? Network identifier. And the remaining, how many are remaining? 64 are used for network and remaining are 64. 64 plus 64, 128. Okay, so the remaining 64 are available for the host addressing within the network. Okay, so 64 for network and remaining 64 for host addressing. Okay, now we have to learn something that is shortening. Yeah. Okay, after this we have to see, as you already know that this is not easy to remember. Whatever the IP address we have here, this is not really easy to remember here. Okay, so we have a method to shorten this one. whatever the long IP version 6 we have here address, we have a method to shorten this one. How we can do that? The first thing is like you can remove the leading zeros. Leading zeros means what? Whatever you can see here, the leading zeros. Okay, this can be removed. So after removing that leading zeros, it will be like 2001 DB8, okay, 85A3 000 okay, 8A2E 370 and 7334. Okay, so after this, these all are what? The same leading zeros, yes or no? So that means the consecutive zeros can be written as what? 10. Okay, so after that, you can write it like this: 2001 DB8, okay, 85A3 colon 0:0, okay, 8A2E colon 370 colon 7334. Okay, next rule is what? If the consecutive quartets of all zeros can be replaced with a double colon. If we have consecutive zeros quartets or segments we have. Okay, so do we have here? Do we have consecutive zeros here? Yes, we have here. Okay, so this can be replaced with a double colon. So how can we write that one after that? So 2001 colon DB8 85A3 double colon 8A2E colon 370 colon 7334. I know still it is really hard to remember, but which is better than this one? Yes or no? This is better than the previous one. Okay. So there is a condition that the double colon replaces a consecutive group of zeros, but it can be done only once in a address. Why? Because let's suppose here also if we have 0 zeros. So how can you understand that where I have to give the consecutive zeros after expanding that one? Okay, so that is the reason you have to use only once here in the IP version 6 address. Am I clear? And if you are expanding that one, so put the leading zeros wherever it is needed, because all quartets which is having how many hexadecimal numbers? 4 hexadecimal characters. Okay. So if a double colon is used, replace them with what? All zeros in a quartet, and then make sure that 8 quartets in a total we have in the IP version 6 address. Am I clear? So this is what the method of shortening and expanding the IP version 6. And yeah, whenever an enterprise request for the IP version 6 address from the ISP, it will receive only 48 bits block. So I hope you know that if you want the address to talk with the internet, you have to buy it. Okay, or no one will give you in free. Yes, whenever you are buying it from the ISP. Okay, so when it comes to IP version 6, what I said, the first 64 bits will be of network bits and remaining 64 of host bits. Okay, so ISP is going to give you only 48 bits. And what about remaining? How much? How many? 16 bits, right? To make it at 64. To make it at 64, how many bits we want? Again, 16 bits. Okay, so that 64 bits will be used for the subnetting here. Okay, so but usually IP version 6 subnets used for what? Uses a /64 prefix length. That means an enterprise has a 16 bits to use to make subnets. Means total 65,535 subnets in a single subnetwork. Can you imagine? In a single subnetwork, how many IP addresses can get? 65,535, because 16 bits are given for the subnetting purpose. Okay, so that can be decided by the enterprise itself. And the ISP is giving how many bits? 48 bits, and the remaining 16 bits you can decide whatever the subnet you want, and remaining 64 that will be for the host bits. Okay, so calculate that one /64 host bits. So we have some other methods, we'll see that one later. Okay, and the remaining 64 bits we use for what? Host bits, as you already know that. And here in the above address, the first three segment, that means these three segments are the 48 bits, they are the network portion or a global routing prefix value. Okay, and then the remaining next 16 bits are for subnetting identifier, and the remaining 64 bits are for host addressing or interface identifiers. Okay, so this is how we write the IP addresses in what do you call IP version 6. Okay, now we will see the types of IP version 6. Okay, so here we have some types. I think I said you. I did. What are the types we have? Unicast address, multicast address, and the anycast address. Somebody said broadcast? No, somebody said. No, we don't have broadcast in the IP version 6. Okay. Yeah, in that first one, global unicast address, GUA. Okay. So global unicast address are IP version 6 addresses that are globally unique and routable on the internet. Okay, what are these? These are the routable IP addresses. Yes, and these addresses fall within the range that is 2000. This is the range of the IP version 6 global unicast address, and even you can call it as a public address of the IP version 6. I hope you already know that in version 4 also we have these kind of types: private IP addresses and public IP addresses. So here this GUA global unicast address is called as what? Public IP address, and the next one is unique local address is called as what? Private IP address. Okay, so 2000 double colon, okay, /3. What is /3 here? What is /3? I mean, what is that? Prefix means what? It's a number of network bits. So here we have only 3 network bits. In public IP address of the version 6, we have only 3 network bits, and remaining all are used for what? Host bits. Okay. So according to that, if you go with the first one, if you convert this into binary. Okay. So 0010. This is how it becomes what? Into binary. And remaining? Okay. So these are the 16 bits we have. And only the first 3 bits are what? Reserved for the network bits. And remaining are, I can say they are a variable. Okay. So if I keep as it is, so I'll get the first initial starting range of the public IP address. That is nothing but the global unicast address. Okay. If I make all of them as a 111, if I make 11111, 1111, and 1111, so what will happen? You will get the last range of the GUA. Okay. So what it will be? What it will be? Yes? 30? 13? Array, look at it. Remember 8421. What it will be? It will be 3, right? 2 plus 1. What? How come it is 13? So this is 3, this is F, this is F, and this is also F. So this is the last range of the 3FFF. This is what the last range of what? IP version 6 GUA. global unicast address. Did you get it? No. Great. I think when we were talking about the design of this IP version 4 addresses, remember? No. Remaining, did you understand? No. In that we used to store the bytes of the first octet. Okay, we used to save or what do you call, reserve. Okay, the first bit or a third bit or second bit they used to reserve. Okay, I hope you remember that in the class A the first bit is used. First bit is reserved as a 0 and remaining were what? Variable. Remember? So if I make all of them as 0, 0, it will become the first starting range of the class A. And if I make all of them 1, 1, 1, 1, what is the range? 127. I'm talking about the version 4. Okay, so it's just what? The conversion. Don't get confused. Okay, and I already said you what is the size of a one single character in the hexadecimal number here in version 4, 6? What is the size? 4 bits. Okay, I have written 4 bits here. 4, 4, 4. Okay, here also 4, 4, 4, 4. Okay, if you convert this into again hexadecimal, it will be like this is a 3. Okay, because of this rule, you can remember this 8421. What is the rule here? 8421 means what? It is the value of that particular number. Wherever there is a 1, that will be added here. So if I am writing 1, 1, 1, 1 means what? You just need to add all of them. 8 plus 4? 12. 12 plus 2? 14. 14 plus 1? 15. So total it will become 15. But we don't write the 15 as 15 in the hexadecimal. We write it as what? So that is what the F is. So this is how it becomes what? 3FFF. Clear? Okay. Yes, Dhiresh, what's happening? Okay. I was talking about this is a public IP address of the, public IP address range which can be assigned to an internet in IP version 6. So you can see that the GOA range, the GOA range spans from 2000 /3 to, as already said you, 3FFF, and all the bits will become what? FFFF. If you make all of them as a 1111. Okay. So starting range will be 2000 and this is the lowest possible address in a GOA range, and it is represented in hexadecimal notation. Okay, and this is the first IP address we can assign on the device. What is that? 2000 4 zeros 4 zeros. So like that you have to complete up to 8 segments here. And when it comes to the next, that is, this is essentially the beginning of the address block of the GOA, and then the ending will be like 3FFF, and then all the blocks or segments will be FFFF. Okay, because here all the host bits are high. Yes. So this is what the highest address in the GUA range, and it is represented at like this. You can read it later if you want. So this is the endpoint of the GUA address block, which is still the part of the globally routable address in the version 6. Okay, this is what the public IP address of the IP version 6, and we call it as a global unicast address. Understood? So don't forget the range of this. 2000 /3. Understood? Because in advanced level, if you go the advanced routing and advanced CCNP, okay, everything you are going to do on this IP version 6 only. Okay, so just don't forget this. So next type What I said, that is nothing but the ULA, unique local address. So this is a private IP address range which cannot be used over the internet. So there also we have the private and public. Okay, the private, what we used to do, the private IP addresses, they are not a internet facing IP addresses. They're used only in the local area network just to make the local communication. So here also we have the same one range. Okay, so these ULAs are not a routable on the global internet, making them ideal for what? Internal use. Okay, so what is the range? It's starting with FC00:/7. So how many bits are given for the network here? 7 bits are given for the network. Okay. So if we convert it into binary, so what it will become? 1, 1, 1, 1, and this one? C means?
12.
Sure. 13. A means 10, B means 11, C means 12, 1, 1, 1, 1, 0, 0. And this 0, 0, 0, 0, and the next is 0, 0, 0, 0. So out of this, how many bits are given? How many bits are given to the network? 4, 5, 6, 7. So these 7 bits are given for the network, and remaining all are given for what? Host. Okay, that means they are a variable. Okay, if I make all of them as a 1, 1, 1, so you already got the first starting range of what? ULA, unique local address, that is FC00. If I make all of them as 1, 1, 1, so I'll just take the 7 bits as it is because they are reserved for the local communication. So 1, 1, 0. So these are the 7 bits. And remaining, if I make it as a 1, and remaining bits are also 1. Now tell me what it will be. So obviously it will become F, this one. 12 plus 1. 13 means what? D it is. And this is F, F. So this is the last range of the ULA. That is unique local address. Okay, starting with what? FC00 and ending with FDFF. Remember this. Okay, how many bits are given to the network? Only 7 bits are given to the network bits here. Okay, so you can see the first 7 bits are fixed like 4 ones, 1, 1, 0, 0 in a binary, which corresponds to the hexadecimal range, that is with the FC00::. Okay, this range spans from FC00::to FDFF. Okay, the same thing I said you here. FDFF. This is the last range of the ULA. Clear? So we have a small header of this ULA. ULA header. So what is that? The first 7 bits are what? Prefix. That means they are given for network. And next 1 bit is whatever the next 1 bit we have, the 8th one. This is called as what? L bit. We'll discuss what is that one. And remaining 40 bits are given for the global ID and 16 bits given for the subnetting, and remaining 64 bits are given for the host identification. Okay. So this always starts with the FC or FD as per the FC00::7 range. Okay. If the L bit, that means nothing but the 8th bit, it is 1. If it is 1, okay, then it is locally assigned. That means this is commonly used in an internal or a private network. If this is 1, that means if it is starting with a FD, this is locally assigned address. That means which is given by the network administrator locally. If that is 0, that is reserved for the future use. So always we use the private IP address with a FD. Okay, because FC is reserved for future use. So currently it is not being used here. Okay, so the 8th bit will help us to find whether it is locally assigned or which is reserved for the future. Understood? And remaining global ID 40 bits, which are randomly generated value that ensures that uniqueness of that network across the whole topology. Okay, so this is critical to avoid conflicts if two ULAs are merged during some organizational mergers or VPN connection. Okay, if some organizations are getting merged, in that case, the IP address is also getting merges. Okay, because this organization will be also having some IP address range and this also having some IP address range. So I mean, whenever you're merging, so how to understand? Okay, this is a unique IP address. So based on this, 40 global unique IP addresses, sorry, the 40 bits, you can identify that one. Okay, next is for subnetting, and the next 64 bits are used for the host addressing. Okay. And the third type of this IPv6 is what? Link local address. Okay. Link local address. So it's a special type of IPv6 address automatically configured on every IPv6 enabled interface. Okay. So by default, whenever you enable the IPv6 on any device, so the device itself is going to generate one IPv6 address. Okay. That is called as what? Link local address. Clear? So these addresses are used for communication between nodes on the same link or a local network segment. This is used for what? A local area network communication. Okay, even though you are not assigning any kind of IP addresses, in that case, you can able to make the communication with the help of this link local addresses. Okay. And these are essential for the operation of IPv6. And even in the absence of global or a unique address, we can use this local addresses or a link local addresses just to make what? Local communication. Let me tell you, this is used for what? Only local communication within the local network segment. Okay. So what is the range of this one? Range is starting with FE80 double colon slash 10. So how many bits are given for the network? 10 bits are. So if you convert this 1111 and E means what? 14 binary. 1101. Are you sure? 14. 8 plus 4 plus 2. Brilliant minds. Wow. So this is how you convert the hexadecimal number to the binary. Okay, how many bits are given here? 10. So this 4, 4, 8 and these two 10, and remaining are the host part. Okay, if I make all of them as 1, 1, 1, what will become 1, 1, 1, 1. So these are reserved 1, 0. These are reserved. And who is that? If I make this 1, 1, 1, 1, 1, 1, now tell me what will become the last range of this one. Yeah, obviously F. This is E. B. Are you sure? What is the number of this one? 11. Sure. 11. B. Okay. Are you copying from somewhere? FEBF. This is the last range of the link local address. Okay. You can see the same thing here. The first 10 bits of the address are fixed like this. Okay. And the range spans from FE80 double colon to FEBF, and all the remaining bits are the FFFF. Okay. And this is a automatic assignment. Like every IP version 6 enabled device automatically generates a link local address for each network interface, even if no global or a unique local address is configured on that device. Okay, even if we just say enable IP version 6, automatically they will generate one IP version 6 in this range. Which range? FE80 to FEBF. Okay, so this will be used a lot here in a different processes. This link local address is used. You can see here, this is mandatory uses of this link local address. So link local address are required for core IPv6 functions like what? What is NDP? I said you. Okay, neighbor discovery protocol. What is that? This is equivalent to ARP of version 6. Sorry, version 4. Okay, we used to use to find the MAC address or mapping the IP to MAC address. We used to use what? ARP protocol in the version 4. And the same like we have one more protocol called neighbor discovery protocol in the version 6. And this uses link local addresses to find the MAC addresses. Link local addresses to find the MAC addresses in the version 6. Okay. And second one is automatic address configuration. As already said you, if you just enable the IPv6 on any device or interface, automatically it is going to configure one IPv6 IP address. Okay, and then communication between routers and the nodes within the same link. Okay, even though if you're not giving the global IP address or a unicast local address, okay, we can make the communication between inside the network. Okay, up to the global, sorry, the what do you call gateway, default gateway, and inside you can make communication within that one with the help of this LLA, link local address. Okay, in detail we can see what is the uses of this. The first one I said neighbor discovery protocol, which device here devices use a link local addresses to discover neighbors and resolve IP address 6 address to the MAC address, which is similar to what? ARP in the IP version 6. And routing. So routers uses this link local address for communication between themselves or with the neighboring devices. As I already said you, just to make a local communication, these routers will use this link local address. Okay, if they are not configured with any GUA or ULA, global unique address or a unique local addresses. Understood? Next is address configuration. Like what? Devices use link local address for initial communication during the IPv6 address auto configuration. And then default communication. If no global or a unique local address is configured, devices can still communicate within the same link using the link local address. And this one has already set you. Okay. This is the third type of the IP version 6. Next we have multicast address. So what do you mean by multicasting? What do you mean by multicasting? One to group or a multiple or a selected number of receivers. So here this multicast address will behave as a broadcast in IP address, IP version 6 address. Okay. Broadcast address in a IP version 6, because you already know that we don't use a broadcast address in what? IP version 6. If you start using the broadcast address, why we don't use a broadcast address in this one? Any idea? Sorry? Okay, no. What was the size of the IP version 4? Just 32. Okay. Here, what is the size? 128 bits. If we use broadcast address, then obviously what will happen? It's going to go to all those devices. Okay. And we don't have a small number here. If you broadcast in a single subnetwork only, it's going to go up to 65,535 devices. Can you just imagine? So here the routers will be very busy to send the same broadcast message only. So this is the reason we don't use broadcasting in IP version 6. So we use a multicasting as a broadcasting, wherever you want to send only selected device data, okay, you can use a multicast addresses here. Understood? So in IP version 6, multicast addresses are used to send single packet to multiple destinations simultaneously. Okay, so only selected devices will be receiving the data here. So they are essential feature in IP version 6, enabling efficient communication with the multiple nodes in a group. What it will do? It will enable us to make the communication between a sender and a multiple receivers. So this eliminates the need for multiple unicast transmission, making it multicast ideal for application like streaming or group communication or network services. Okay, this is where you use the multicast addresses. So what is the range of this multicast address now? It is starting with FF00 with a slash value 8. FF00 :/8. So this is what the range of the multicast address we use in IP version 6. Okay, so you can understand the first two are reserved for what? Network, and remaining are for the host. Okay, even though if I convert it into binary, you will get a FF only. Understood? Because 8 bits are given here. So here we have 4 and here we have 4. Total 8 bits. So the first 8 bits are always fixed as a 11111, or even can say FF in a hexadecimal. Okay. So we have a scope field and all. So that is you're going to learn it later in advanced level. Next we have anycast address. So anycast means what? It is kind of a unicast only. It's kind of what? Unicasting, but it's 1 to nearest. What? 1 to nearest communication. Remember this. What is unicasting? 1 to 1. And multicasting? 1 to multiple or selected. And broadcast? 1 to all. Okay. And anycast? 1 to nearest. If somebody asks you what is anycast addressing, you have to say it like what? It is a 1 to nearest communication where it uses a distance value. Okay, where it allow us to assign the same IP addresses to the different devices, which is connected to the multiple router. Understood? You can see here Anycast address in a IP version 6 are a unique type of a address that allows multiple devices or nodes to share the same IP address. Okay. For example, let's say I'm having the routers. Okay. So to this, some devices are connected. And I have a same IP address here. So let's say whatever the number you can take. So 2001 DB8 colon 1. This is a one IP address. So same IP address we can assign it to the one more device DB8 okay colon 1, and here also 2001 okay DB8 colon 1. So whenever this system wants to send a same message okay via any cast message, then what it will do, the destination IP address will be what, the same 2001 DB81, and again it will see what, it is delivered to the nearest node in terms of what, routing distance. Routing distance means what, again it is a AD value. Okay, so that is configured with that address. Anycast is designed for one to nearest communication. If you want to send the same data to the multiple at the same time, okay, you can send it using with the anycast addressing. Whatever the IP address which is having the same IP address in a different network or with connected to the different router, they are going to receive the same data. So what's happening here? This is also kind of what, broadcasting only, right? But one to one. Understood? So some key features. So it will allow us to have a shared address. Like multiple devices can assign the same IP version 6, but the condition is like they must be reachable via different routing paths. I think I have shown you the same thing here. They are reachable via different routing paths or different routers here. Yes. Next is one to nearest communication. Like packets sent to an anycast address are delivered to the nearest device based on the routing protocol's decision. For example, shortest path first. Okay, whatever the AD value it uses, whatever the protocol it is using here. Okay, based on that, it is going to send that. Okay. Next is it is derived from the unicast. What is that? Anycast addresses are not a separate type of IP version 6 address. Instead, they are a unicast address that are configured and used as a anycast. What's happening here? This is also one-to-one, right? So this is sending, this will be receiving. Only selected devices they are receiving where it is configured with the same IP addresses. So that is also kind of what, one-to-one unicast communication here. Yes. And for this one, we don't have any specific prefix value. It uses the same what we use in the multicast and the link local addresses. Okay, they are regular unicast addresses used in a communication here. Okay. And other than this, the GUA, ULA, link local address, and then the multicast address and the anycast address. Other than this, we have some other two types. Okay. So what are those? Remember this? Remember what this was used for? Yeah, it is of IPv4 only. What it is used for? Default. Forgot already. Yes. So default routing. Any address, any IP address under any subnet mask 0.0.0.0. IP address 0.0.0.0 subnet mask. You are going to send this data to the next hop. Okay. So the same here also we are having. Okay. So we call it as what? Double colon. Okay. If you use this double colon, this is a unspecified IP version 6 address. It can be used when a device doesn't know it's a IP version 6 address yet. Okay. So this is used in a default routes. Okay. So that will be double colon /0. Yes, any IP address and any mask. You don't have subnet mask here. Okay, I mean no network bits are present here. Yes, so it is equivalent to what? 0.0.0.0 of a IP version 6. Other than this, we had one more, that is what? Loopback address. What was the loopback address? What was the loopback address? 127.0.0.0 with a slash value 8. So it is a loopback address of IP version 6. Double colon 1, it is called as what? Loopback address. Okay, which is used to test a protocol stack on a local device, and messages sent to this address are processed within the local device but do not send it to the other device. Okay, which is equivalent to 127.0.0.0 with a slash value 8. Okay, so these are the two special addresses we have in the IP version 6. Okay, after this we have a method called, very important in IP version 6, that is called modify EUI. Modified EUI method. Okay, what is this? This is used to find those remaining 64 bits for the host. Those remaining 64 bits for the host. The first 48 be given by the ISP, and enterprise is going to find the subnet by using that 16 bits. And what about the remaining 64? So they are going to be calculated with the help of this modified EUI 64 method. What is this? This is EUI stands for what? Extended Unique Identifier. It's a method of generating IP version 6 automatically using the device's MAC address. What it uses? It uses a device's MAC address to find this 64 bits. But what is the size of the MAC address? What is the size of MAC address? 48 bits. Then how are we gonna find this remaining 16 bits? We need 16 bits more, right, to make it as a 64. So with the help of this modified EUI, we are going to do that one. Okay, so modify EUI 64 is a method of converting MAC address that is of 48 bits into the 64-bit interface identifier. Okay, so this interface identifier can then become the host portion, that is /64 of a IP version 6. Okay, you can see the method how to convert the MAC address into full IP version 6 IP address. Let's suppose the MAC address we have here, that is 1 2 3 4 5 6 7 8 9 0 AB. 0 AB. How many segments we have in MAC address? How many segments? 6 segments we have. Okay, 1 2 3 4 5 6. Okay, that means the 48 bits. Clear? So first what they will do? First they will divide the whole MAC address into half. I mean, they are going to write it like this: 1 2 3 4 5 6, and remaining 7 8 9 0 AB. So 6 digit this side and 6 remaining that side. And to make it as a 64-bit, they are going to add one number, that is FFFE. FFFE. So now this becomes what? 64 bits. Okay. So insert FFFE in the middle, so that will become like this, and invert the 7th bit. Invert what? 7th bit. Invert means what? What do you mean by inversion? Invert. Yes. If it is a 0, make it as a 1, and if it is a 1, make it as a 0. Inversion. Binary inversion. Okay. Invert. Yes. So which bit has to be inverted? 7th bit. Which is 7th bit here? 7th bit. Which is 7th bit. Whatever the one you can see, this is called as our 7th bit. Okay, we have to invert it. Now it is 1, just make it as a 0. So it will become what? It will become 1, 0, 3, 4, 5, 6. This is how it becomes the EUI. The next 64 bits for the host address. Okay. So you may ask like why to convert or invert the 7th bit. The reason is like MAC addresses can be divided into two types. One is what? UAA and second is the LAA, universally administered address, and second one is locally administered address. Okay. So what is this? Which is assigned by the manufacturer to a device. UAA means what? Which is assigned by the manufacturer. And locally administered means what? Which is manually assigned by the administrator on the CLI of the device locally. Okay. So UA means what? Which is assigned by the manufacturer who is manufacturing that device. And LA means what? The administrator himself, he just changed that one. Change the, what do you call, 7th bit. Okay. So that will be showing it as what? The address, what you can see, this is locally assigned. Understood? And you can identify UA or LAA by the 7th bit of the MAC address called UL bit, universal local bit. If the UL bit is set to 0, then that is a universally administered, and UL bit is 1, then that is called as what? Locally administered. Okay. Next, we will see the header of the IP version 6. What is the size I said? 40 bytes is the size. It's a fixed one. What was the size of the IP version 4 header? 22, 60 bits. Bytes. Okay. So let me tell you, this class may extend up to 8, 10. Sorry, 10, 30. Is that okay? Okay. The first IP version 4 header, the first field is what? Version field. Okay. So version field is of 4 bits where it is going to identify the IP version's version. So it is set to version 6 for the IP version 6. And the traffic class. So this field we had in IP version 4 also, called what? Service type. What it is used for? It is used for the quality of service, just to prioritize the data. Okay. So it is used to specify the priority or a quality of the service for packet, similar to the differentiated service code point in a IP version 4, DHCP. Okay. So flow label, it is used to identify a specific flow of a packet for efficient routing and handling by the routers for video and a voice traffic, how the flow must be. This is given as a highest priority. So that will be forwarded as a highest priority, right? So that will be done in the flow label here. That is of 20 bits. Next is payload length. It specifies the length of the payload. That is nothing but the data in bytes, excluding the header size. Okay. Next is next header. It's gonna identify the type of the next header. Like means what? What kind of protocol which is being used as a transport layer, whether it is a TCP or it is a UDP. Next is what? Hop limit. It is similar to what? The field what we had in the IP version 4, that is TTL. Okay. So it specifies the maximum number of hops a packet can take before being discarded. Okay. So it is similar to what? TTL in the IP version 4. Okay. So next we have source address and the destination address. Both are 128 bits. Yes. So this is what? A small header of the IP version 6. Now we can see some key differences between the IPv4 and the IPv6. So here in the version 6, this header size is what? Fixed. As I said, 40 bytes. Okay. While the IPv4 header have 20 to 60 bytes. Next is simplified headers field. How many fields you didn't see here as compared to the IPv4? Did you find any checksum field? Did you find any checksum field? Any option field? Fragmentation and header length? No, we didn't find any kind of these fields in the IPv6 header. Okay. And larger address space like source and destination addresses, they are having the size of 128 bits. So just compared to this IPv4, this is bigger than that one. Okay. And here we have one more extension header. That is the additional option are handled via extension header, which are processed sequentially only if it is required. Did you find any option field here in IPv6? No. Yes, we have one equivalent field of that one, that is an extension header. Okay. If you want extra data can be carried with the same header, okay, you can add this extension header to the actual IPv6 header only if it is required, not every time. Okay. Okay, next we have how exactly they will find the MAC addresses. The R related explanation here. So it uses a multicast address called solicited node multicast address. What? Solicited node multicast address to find what? The solicited node multicast address is a special type of a multicast address. It is used in IPv6 for efficient neighbor discovery. Okay. So it is a feature of a neighbor discovery protocol that helps to reduce the scope of a multicast traffic on a IPv6, particularly for what? Functions which are like what? Like address resolution, similar to what? ARP in the IPv4. Okay. This solicited node multicast address, they are totally reserved. Okay. That reserved is what? The range is FF02 colon 1 colon FF. So this is the solicited node multicast address. Okay. Whenever the devices, they are getting this kind of a request from this IP address, okay, they find it this as what? This is a NDP request. Understood? If you're using the whole multicast address, again they have to segregate this one. So this multicast address is for what? Okay. So that is the reason what they have done. They have given a separate range for this NDP protocol. The separate range of the multicast address for the NDP just to find the neighbor in the topology. Okay. The solicited node multicast address is derived from IPv6 unicast or anycast address by appending the last 24 bits of the address to a fixed prefix. You can see the FF02 colon, it's a multicast address prefix that specify the link local scope, and double colon 1 colon FF, it's a reserved portion for the solicited node address. So this is only going to let you know that this is a NDP request packet. Okay. And x-axis means what? The last 24 bits of the corresponding IPv6 are a unicast or a anycast addresses here. Okay. So how exactly it works? We'll see. If a node wants to determine the link layer is nothing but what? MAC address. In IPv6, it is called as what? Link layer address. Okay. Of another IPv6 node on the same local network, the network will send a neighbor solicitation message. It is kind of what? ARP request packet. Okay. So equivalent of this ARP request packet is nothing but what? Neighbor solicitation message. to what? Only to those devices that is a solicited node multicast address corresponding to the target IP version 6. And against the ARP request packet, what packet used to come? ARP reply packet. So in this case, it is a neighbor. What is that? Yeah, neighbor advertisement. Okay. Solicitation means what? It's a request packet. Reply means what? It's a advertisement packet. Okay. So the target node listening for its solicited node multicast address responds with a neighbor advertisement message containing its link layer address. Okay. So this is how it's gonna learn the MAC address. Yes. Don't worry, we are about to end. And after that, we have to do the practical also. So that's what I said. It's gonna take a longer time. Okay. Okay, next is NDP, Neighbor Discovery Protocol. What I said, it is equivalent to ARP of the version 4. So the ARP-like function of NDP uses a ICMP version 6 and a solicited node multicast address to learn the MAC address of the other device or a host, I can say. Okay. So here it uses two messages as I said you. What are those? One is a neighbor solicitation and second one is a neighbor advertisement. Neighbor solicitation is nothing but what? ARP request packet, and this is a reply packet. Okay. So neighbor solicitation, it uses a ICMP version 6 and the port number is what? 135. And neighbor advertisement, it also uses same ICMP version 6 and the port number is 136. Okay. So another function of this NDP allows host to automatically discover routers on the local network. Okay. So this is used for what? To find the other host. And if you want to find the default gateway or the other router inside your network, you use these messages. What are those? Router solicitation and a router advertisement. Okay. So router solicitation, the port number is what? 133, which is sent to a multicast address that is FF02:2 to all the routers. Okay. So ask all the routers on the local link to identify themselves just by confirming your MAC addresses. Okay. So sent when an interface is enabled or host is connected to the network. And against that one, router is going to send what? Router advertisement on the port number 134 with a multicast address that is FF02:1 to all the nodes which are connected here. Okay. So the router announces its presence as well as other information about the link. And then the messages are sent to in response with the RS, router solicitation message. And they are also sent periodically even if the router hasn't received any kind of RES. Okay. So this is how the devices, they will learn the MAC address in the IP version 6. So two more features we have here. One is Slack and second is a DAD. So Slack, in short, we can say it as stateless address auto configuration. Okay. Here it is a mechanism that allows the devices on an IPv6 network to configure their own IP address without requiring manual configuration or a DSCP server. And it is the core feature of IPv6, enabling simpler and more dynamic simple setups. Whenever you enable the IPv6 on the device, okay, so they will run with the Slack. Automatically, they will assign an IP address on itself. Okay, that is called Slack. So with the help of, again, you can use the UI64 just to have the 64 bits of host devices. Next is what? DAD. It's nothing but what? It's equivalent to grp, I can say. Okay. So duplicate address detection. So what will happen? Duplicate address detection allows the host to check if the other devices on the link are using the same IPv6 address or not. Okay. What the grp will do? What the grp will do? grp will also do the same thing, right? That is used to just find the duplicacy of the IP address. So here also it does the same thing. Okay. And remaining, we can learn it. Read it later. Okay. So next, go to the practical. I think still we have time. So today, now I'll tell you how to assign the IP address on the interface. Okay. And static routing. That's it. And the default routing, we have the commands here. You can practice it later. Don't forget. Okay. And then we have network route or a host route, or even you can have the floating static route also. Okay. Make sure you are going to practice this one later. Clear? Okay. So now let's go to the your favorite CPT. Is there anybody online? Oh, Murali, you connected online. Yes, Murali, are you there?
Sir,
Okay. Now I have a question here. I want to make the communication between this PCs without assigning any kind of IP address, like IPv4 and IPv6 also. Is it possible? Murali, are you there?
I'm there, sir.
Are you thinking? Are you answering or no?
I'm thinking, sir.
Thinking, okay. We don't have a lot of time.
I think we need the IP address for transferring of data packets, no, sir.
But I said we are not going to assign that one.
I think communication won't happen, sir.
Sure. Mr. Narendra, what do you think? Narendra, are you there? Vaishnav? Anybody here? Aap request. Back. Wow, good. Is it? Tell me. PSCP. Okay, good. I said I'm not going to give any kind of a static one or even DSCP. Can we do the communication? That's why I opened this one, just to have an idea. What I said, we discussed one type of address, that is link local address. What I said, even though you're not assigning a global unicast address or a unique local addresses, this will help us to make the communication locally. Okay. So can you find any link local address here? Can you? What is the range of that one? Is it starting with FA80? So this is what the range I said. Okay, great. So copy this one, and if I say ping, yes, yes, without assigning the IP address also, we can able to ping the device. Clear? Great. Now I'll tell you how to assign the IP address. Other than this link local address, we are going to assign the IP address. Okay. So I'm going to use the global unicast address, that is 2001 double colon DB8 colon 1. Okay, a small number. And just say tab, and after that you have a prefix value. So what is the prefix value? You already know that, 64. Okay, done. So let's go to the second PC and assign the IP address. The config, and go to desktop or configuration, and here 2001 double colon TB8 colon 2, and 64 is the 1 double colon DB8 colon 3, and next we have 64. That is done. Let's go to desktop and say ping 2001 double colon DB8 colon 1. It says that I'm pinging. Okay. What about 2? That will also ping. Okay. If you want to ping itself, it says that yes, I'm pinging. Okay. So this is how to assign the IP address on what? PCs. Okay. Now let's go to the router. Let's have this router. Okay. So instead of that, I can take the same. Why to waste? Done. So let's stick this bit side. It is direct routing what you are going to do. Are we going to run any routing protocol here? Are we going to run any routing protocol here? No. Why? Why? Why we are not going to? Because guys, they are directly connected. Okay, if I want to make the communication from this network to this network, it's already directly connected to the router. In that case, do we want to have any routing protocol? No, right? If I'm going to connect one more router here, in that case, we need the routing protocol. Yes. So here it's already assigned with the IP addresses, but let's give the default gateway here. There is 2001 DB8, okay, colon 10, okay, and just copy the same and paste it on gateway.
Single column, I guess.
Again, single colon. Yeah. Okay, done. So let's assign the IP address here, DB9 2001. Obviously, I have to change the network here. So that will be DB9 and colon 1. Okay, the slash value 64. And copy this and paste it here. 10 will be the gateway. Okay. So let's go to the second one. IP configuration and paste it here, make it 2 and 64 is the and paste it. Let's go towards 10, right? Yeah, DB9 10. And here also do the same thing. Desktop IP configuration, and then paste it, make it as a 3, and then 64, and then the gateway will be 10. Okay, done. So let's assign the IP address on router interfaces now. Let's take this bit this side, CLI, and then enable config interface gigabit Ethernet 0/0, and here what we used to say IP address, but this time you have to say IPv6 address. Okay, then only it will be taking your IPv6 address. So 2001 double colon DB8 colon 10 with a flash value 64. That's it. Just say enter and no shutdown. And after this, you have to say IPv6 enable, because they already know that router doesn't support IPv6 by default. It only supports IPv4. So that is the reason manually you have to enable the IPv6 on the routers. Okay. Enter. Done. So let's go to, yeah, there only the second interface. So exit and interface gigabit Ethernet 0/1, and the IP version 6 address will be 2001 double colon DB9 colon 10 with a slash value 64. And after that, let's see what I've given there. DB8. How come it is overlapping? Overlapping means says that on other end also I'm having the same network. IPv6 2001 DB9 colon 10 the slash value 64. No, it's not. Now shut it down, and then you have to say IPv6 enable. Okay. So exit this one. If you say do show IP version 6 route, this is a routing table of the router here. Okay. How many routes it has? Two routes, 2001 and 2002. Okay. So one more that will be by default connected here. What is this? FF00. Which address is this one? With a slash value 8. By default, if you enable the IPv6, it will be there in the routing table. What is that? FF00. This is the type of which type? What is the multicast address type? What is the range of that one? Same FF00 with a slash value 8 only. Okay. So by default, it will be there in the routing table. Yes. So if you go here and if you say have to change, I guess here to make it as it's a DBA. Okay. Receiving 2002 double colon DB. Yes. Ping 2001 double colon DB8 1 says that I'm pinging 2002 DB8 that is also pinging. Let's go here and ping its own DB8. Two thousand two DB810. 2002 DB810 1 2 3. Huh? Yeah, if you want to go for huh? Cisco. क्या सोच है तेरे?
Blocking the other.
Yeah, one thing I forgot to do here. That is why I'm not getting this one. So let's go here. Let's connect the same. I think as I already said you that the router doesn't support what? IP version 6 by default. Okay. And here I forgot to enable IP version 6 unicast routing. Routing also you have to enable here. Okay. This time if you ping okay. So this what you have to keep in mind. What is that? When you are dealing with IP version 6, don't forget to enable everything. Enable IP version 6 also on a individual interface. And even if you are doing the routing also, you have to enable routing by saying enable unicast routing. Okay, sorry, IP version 6, unicast routing. Okay. That only. Go here. Configuration, no, it's already done. Let's do this. Pick route. I'm not gonna have this multiple devices here. I'll keep only one. Okay. So let's take this side and this side. Let's take one more router. Put it in the middle and a switch and a PC. Okay. Great. So try to connect them.